Hey there, welcome to our last video for Unit 7. What we're really going to do here is take a look at polygons on a coordinate plane. This is a big topic that exists in the ACT, so hopefully you get a nice view of this, and the practice and the application contains some ACT problems, so hopefully you take a look and you're comfortable with those. So let's go ahead and jump into it. When we do these, we need a couple of formulas. The first is the distance formula, and you already have this written down somewhere. Then we have our midpoint formula and the slope formula. So these all exist. We learned these back in units 1 and 2. So you should have them written down somewhere, but if you don't, go ahead and write them down. All right, with these problems, we're going to have to utilize them. So here's kind of the key times that we're going to use each of these formulas. So the distance formula, since we're talking mostly probably about quadrilaterals, but we are going to throw some triangles in here, we're going to need to use that when we're going to show that sides are going to be congruent. Because if we can show opposite sides are congruent, or if we can show diagonals are congruent, that's kind of showing, do we have a rectangle, or do we have a trapezoid, or do we have parallelograms in general? We can show diagonals are congruent, like I just said a moment ago, which would show that we have ourselves a rectangle. We would need to couple that with something with the sides, but you get that idea there. The midpoint formula, obviously we're going to need to do that if we need the midpoints of a side. You're going to see a problem momentarily where we're going to use the fact that we need to find the midpoint of a side. Also, because for parallelograms the diagonals are bisecting each other, we can find, do we have a midpoint, and this is the midpoint where these guys are crossing here. Okay, and then finally the slope formula, that's dealing with, do we have parallel or perpendicular lines? So we use the, we want to determine if opposite sides are parallel. So if we have the one pair of opposite sides for a trapezoid, or if we have two pairs of opposite sides that are parallel for the parallelograms. We also can show if we have ourselves perpendicular lines. So if we have the opposite reciprocal, that means these lines are perpendicular, so they're forming a right angle. And so we want to show that, well, we want to show we have right angles, and that would determine if we have a rectangle or a square, or we can also show the diagonals are perpendicular to each other, or the sides. Sorry, I had those backwards. So we got diagonals, or you got the sides are perpendicular to each other. All right, so let's jump in and do an example here. So I have a triangle DEF and specific vertices here, and I want to determine, well, what kind of triangle is this? We did do problems like this. You probably saw some of this back in unit 3 or 2, 4, sorry, 4, when we did congruent, when we plotted things and we found distances. That's kind of what we're doing. All right, so plot some points. We've got D is at 0, 0, E is at 1, 4, and F is at 5, 2. So after you plot all these, we're going to connect the dots. All right, so determine if triangles are scaling isosceles or equilateral. That means we're focusing in on our sides, because that's classifying by size, not the angles, okay? All right, so then we're going to use our distance formula, because that's how we calculate side lengths. So what I like to do in place of the distance formula, because it's the same idea, is really use the Pythagorean theorem. So if I want to find the length of EF, what's formed is a right triangle by going up and down. I can see the one leg, and then the left to right movement would be my other leg. And if you did the distance formula, you're going to find these same things, and we talked about that in the past. Okay, so I know for EF, I'm going to go, since I'm going down 2, that's 2 squared, and then I'm going over 1, 2, 3, 4, that's 4 squared. And so using Pythagorean theorem, I'm going to add them and square them, or square them and add them and take the square root. You really don't have to go through and take the square root if you don't want to. We're just going to check to make sure the number underneath is the same. So EF is the square root of 20. So now let's do the same process with FD. So if I count, I'm going down 2, so I know I'm going to do 2 squared, and then over 1, 2, 3, 4, 5. So I'm going to do 5 squared. So I got 2 squared and 5 squared. So that's 4 plus 25, which altogether is 29. So far, I know that it's not equilateral, but could still be isosceles or scalene. So we're going to check our last side, which is ED, and I'm seeing going up 1, 2, 3, 4, and over 1. So I'm doing 1 squared and 4 squared, which is 16 plus 1, which is 17. 3 sides that are not equal to each other, that means it's scaling. Okay, so that's the process you're going to take if I give you some points. All right, this guy here, we've got an isosceles trapezoid that has these specific vertices. We want to know what special quadrilateral is formed by connecting the midpoints of the sides. Okay, so that's the key word here, is the midpoints. Let's go ahead and get that isosceles trapezoid on there. I got A is at 0, 0, B is at 2, 4, C is at 6, 4, and D is at 8, 0. So it should look something like this. All right, now we're going to find the midpoints, because that's the key word there. So what I'm going to do is use the midpoint formula. And now you don't have to. Some of you might be able to eyeball it, but if you can't, we're going to go ahead and use the midpoint formula to find the midpoints. So I'm first going to do it between A and B. So 0 plus 2 over 2 and 0 plus 4 over 2 gives me the coordinate 1 comma 2. So I'm going to plot that right there. And you might have been able to eyeball that on your own. I'm going to go ahead and do that with BC. So 2 plus 6 over 2 and 4 plus 4 over 2. We get 5 comma 4. And then I'm going to repeat that same process for the other two sides of this. So what I get here are 4 points, and I'm going to go ahead and connect those dots. I want to know, this question's asking, I want to know what is the shape inside. And so I know I have 4 sides. So the first thing I like to always do is check for side lengths. Because when I check for side lengths, if I only have an opposite sides being the same, it could either be a rectangle or it could be just a parallelogram. But if I have 4 sides the same, then I can do square, rhombus, or parallelogram. So what I'm going to go through is show what the side lengths are. Well, if I take a look at every single one of them, I'm going down 1, 2, over 1, 2, 3, down 1, 2, over 1, 2, 3, and then over 1, 2, 3, up 2. Do you see how all of them have up 2, over 1, 2, 3? I've got that 2 and I got that 3. So I'm going to go do 2 squared plus 3 squared, which is the square root of 13. Every single one of those is going to end up being the square root of 13 because every single one of them has an up and down movement of 2 and a left to right movement of 3. So now I know at least here it can be a square, but I don't know that yet, but it's at least a rhombus. So what I want to check now is to see if it's a square. In order for it to be a square, we can check a couple of things. First, I'm gonna check for right angles at the sides here. Okay, so the purpose of that is to see if I have perpendicular lines here, which means there's opposite reciprocals. That means that these are perpendicular and forms a right angle. So that's my next step here. So I do the distance, and now I'm going to find the slopes. Well, for the slope of this line here, it's -2 because we're going down 2 over 1, 2, 3. And then the slope for this line, we're going up 2 over 1, 2, 3. So I have -2/3, and then I have 2/3, and the opposite sides are the same, okay? Well, these are not opposite reciprocals. They're opposite signs, but they're not reciprocals of each other. So we know we don't have a right angle going on in each of these vertices here. But I do know all 4 sides are the same, so therefore I can say it's just a rhombus, okay? All right, last one with these types of problems. I'm going to plot the points -1, -1, 2, 2, for R, 6 comma 1 for S, and 5, -2 for T. And I want to know if this guy's a rectangle. Now, most of you are probably looking at this like saying, no way. But if I want to show it, okay, so like if this was a problem on like an open response problem, and I want you to show it, you would show it using slopes because rectangles have those right angles. So I'm going to go through and try to find the right angle. I'm going to use it for RS and ST and see if it's opposite reciprocals. So I see my slope for RS is down 1 over 1, 2, 3, 4, so that's -1/4. And then ST is up 1, 2, 3 over 1. So that's enough for us to say that these guys are not opposite reciprocals, therefore they are not perpendicular, therefore it is not a rectangle. Okay? All right, so that's the first half of this lesson. The second half of this lesson is dealing with variables. This is this kind of stuff you're going to see on the ACTs, coming up with coordinates, not giving specific numbers. Okay, so here's an example of that. What are the coordinates of the vertices here? I know that the SQRE is a square where SQ is 2A, and the axes are bisecting the side. So the axes are bisecting the sides, means these guys are cut in half. So let's start labeling things. Well, it's a square, so I know that QR has to be 2A. If SQ is 2A, then ER is also going to be 2A. So kind of continuing that thought where the fact that these axes are bisecting each other, if these guys are 2A, then this is right in half. That means these lengths from here to here are A, and that process is going to repeat down here. And that's kind of what we're going to use in order to find these vertices. Because we know A is some number, just placeholder, like the number 5. So if this is length 5, and then I'm going up length 5, I can identify that as 5, comma 5. Well, instead of the number 5, I'm generalizing it with the letter A. So if I'm going over A and up A, that means this point Q has to be AA. Now keep in mind those signs of the X's and the Y's as we move to the different quadrants. In quadrant 2, over here on the top left, the X values are negative. So I'm going down A, which means the X value is a -A. Same thing when we talk about E. Both the X and the Y coordinates are negative. So if I go left A and down A, both of them are negative. And finally in quadrant 4, the Y values are negative. So all of the coordinates, this is what your final thing would look like. Like I said, keep in mind X values or Y values where they are negative. So as long as it's reflecting the fact that this length here is 2A, we can go ahead and say that. Let's take a look at another example here. We want to know the vertices of these three here. So all I know is that TI is 2A, and then the y-axis is a median. So once again, I know that this length here is 2A. When it's a median, that means it's cutting this piece right in half. Okay, it's going from vertex to the midpoint, which means the length from 2 to the origin and I to the origin are both going to be the same length, or in other words, A. Okay, so just like in the last example, I can go through and find those. Since I'm going from the origin over and I'm sitting on the x-axis, that means the y value is going to have to be 0. Now, when we start talking about r, that's a little bit different here. Now, I don't give you any information about the height of the triangle, so that's kind of what we have to keep in mind when we're trying to find the length r, is that I can go ahead and say, all right, well, I've not given any information, so now at this point, you're going to go ahead and make the value for the height be just b. So you can make up a letter at that point. This is only if you're not given enough information, okay? Go ahead and hit the pause button and give yourself a try and see if you can come up with those. And in a couple seconds, I will go ahead and display the answers. Okay, so let's see how you did with that one. For number 3 there on the left, this is what you got. And for number 4, this is what you got there. We should not be using any new letters at this point because we had enough information. All right, this is our very last example. I promise. I know it was heavy in examples, this guy here. So the diagram shows a parallelogram with the vertex at the origin and one side on the x-axis. We want to know the coordinates of D. Okay, so what I see here is I know I have myself a parallelogram. And so we got to think of those properties of parallelograms. I know that the diagonals are bisecting each other. So if that's the case, this letter D here has to be exactly in the middle. Okay, so what we're going to essentially use is the midpoint formula, okay? Again, that's because D is in the middle of both CA and of BO. So that's what I'm going to use. Now, there's two ways we can do it. We can find the midpoint for CA, so using those guys there. And I'm just going to combine 2B plus 2A divided by 2 and 2C plus 0 divided by 2, either one of those cases, and just simplify. So both of these are divisible by 2, so I can divide that out, leaving with A plus B. 2C plus 0 is just 2C. Dividing that by 2, I just get left back with C. I can do the same process, but with O and B. So in this one here, though, it's going to be 2A plus 2B plus 0 and 2C plus 0, and then we're just going to simplify that down. Either case, you should get the same exact thing, okay? So I'm just plugging all these things into a formula, and I am simplifying as far as I can go. You can do the same thing with the distance formula as well. What's important here is that you recognize that the parallelogram and its properties before we can decide how do we find that actual value here, okay? So make sure you have that flow chart in front of you so you know what properties belong to what. So as you start solving and starting to identify these key variables and these points here, you know what to do. All right, go ahead and hit the stop button and start that practice.